introduction to statistical learning in chapter 5. I think this is the very last question of this chapter, question 9. So we're going to consider the Boston housing data set from ISLR2, and then we're going to go through a bunch of questions. So they're posted up here on the Colab sheet, so you can look at it for yourself, but we will look at them one at a time as we go along. Okay, so we need to install and load the ISLR2 package as well as the boot package, which we will use for bootstrapping, which we need to do in this question. I've already done this, so I'm going to blot these out while I run that part right there, just to speed it up. And we need to load the Boston dataset, which is in the ISLR2 package, I believe. And notice that I'm just relabeling it D, which is just a habit of mine to reduce the typing. Okay, so part A, so we need to provide an estimate for the population mean for a variable called medv right here. Okay, so this column right here, and we'll call this mu hat. Okay, so here's mu hat here, and notice that this is just very simple. So we have mean, and then the thing we want to take the mean of. Okay, and so we get an answer right here. Now in part B, we want to estimate a standard error of the mean. Okay. And interpret this result. So it gives us how to calculate the standard error without bootstrapping, kind of the analytical formula, which is just standard deviation divided by the square root of the sample size. And here the sample size is the number of rows we have in our data. So we just take the square root of that. So anyway, so that gives us an estimate of the standard error of the mean estimate of the variable. So, okay. So now in part C, we're again going to estimate standard error, but this time we're going to use Bootstrap and see how it compares to what we just calculated analytically. Okay. I mean, we computed it computationally, but with an analytical formula. So, I'm going to call this Bootstrap SE. So we call the boot command, tell it what data we want, and then what function we're trying to estimate here. Okay, so we run this and we get this right here. So here's our estimate of the mean, okay, which is pretty close to that estimate, and then we get an estimate of the standard error, which is pretty close to the analytical form of the standard error. I suspect if we did this again, yeah, so we get slightly different values for the standard error, but anyway. Okay, so moving on to 9. So we want to compare this estimate of the standard error. Well, no, sorry, let me back up here. So we're going to take this standard error and we're going to calculate approximate a 95% confidence interval using that guy right there. And then we're going to compare that to the confidence interval that we obtain with the t.test command, which will give us, kind of an analytical solution to it. So from the boot command here, I couldn't easily find a way to just isolate the standard error here. So forgive me for just hard typing it in, which is not a good practice, but that's okay. I guess we're working on the concepts here. So I'm going to calculate the bottom and the top of the 95% confidence interval with the bootstrap standard error, and then this t.test command will give us an analytical answer. So here is our 95% confidence interval with the standard errors produced by the boot command. Okay, and then here is the 95% confidence intervals given to us by t.test, and of course you see that they're pretty darn close. Okay. Now in part E, we're going to calculate the median. So we've been looking at this variable right here, medv, and we've calculated the mean and the standard error of the mean. But now we're going to calculate the median, and then look at and then find a standard error of the median. So finding the median is very straightforward. We just use the median command. Okay, and that gives us this value right here. And now we want to estimate a standard error for median. And so it's situations like this and more complicated situations that bootstrapping really shines, okay, and explains right here. There's no simple formula for computing the standard error of the median. So instead, we need to estimate the standard error using the bootstrap, okay? So that's what we're doing here. So I'm going to calculate the median with the bootstrap, and here's my formula right here. And this is going to give us an estimate of the median, which should be around 21.2. In fact, it is. And then also a standard error of the median. Okay. So now we have a standard error estimate of the median. All right. And so the median is one of the quantiles. It's the 50th or 50% quantile. And I said that, I said and was supporting what the book is saying, that there's no simple formula to find the median, the standard error of the median. And even for uglier statistics, or maybe more seemingly abstract statistics, like the 10th percentile, there's no way to find there's not at least a straightforward way that I'm aware of to find the standard error of the 10th quantile. So in part G here, we're going to just calculate the 10% quantile, which is this. Okay, with this formula right here, we use quantile, the data, and what quantile we want, 10%. But now we can get a standard error with again the boot command here. Okay, and so we run that, and again we get a basically identical median, and we get an estimate then of the standard error. Okay, that is it for this one, and I guess we are now moving on to chapter 6.